Warahmatullahi wabarakatuh. My name is Muhammad Safiq Hizami bin Suhaini. The title of my study is Study on Dynamic Performance of Armour Personnel Carrier due to Generic Armour Vehicle Impact. My supervisor is Dr. Shabilah bin Sulaiman and my co-supervisor is Encik Asri bin Azizul. For the content of my presentation is research background, problem statement, objective, scope, literature review, methodology, result, and conclusion. Background. Light armor vehicle is the term for the lightest weight class military vehicle category. The weight of vehicle is higher than the other commercial vehicle. The suspension need to be more sturdy to support the weight of armor vehicle. The use of APC is to bring armor to the war zone, which it will make the vehicle heavier.
Kau baca.
For the problem statement, standard suspension cannot carry the load produced from the weapon. Next, suspension system is not suitable and suspension system cannot accommodate the additional load that produced from the weapon. Land Cruiser is a SUV that can fit until 8 person, but for APC, which the weight is 5,000 kg, the suspension system may be not suitable because the weight will be 2 times more than stock. The objective in my study is to study the suspension system behavior of Armour Personnel Carrier (APC). The second objective is to simulate standard vehicle and APC suspension model based on parameter of Toyota Land Cruiser J200. And the last objective is to compare standard vehicle and APC suspension performance during ride and handling condition. For the scope of my study, for the study, the software will use CarSim software only. The second scope is the simulation will be carried out using virtual vehicle based on Toyota Land Cruiser J200 parameters only. The next scope is the simulation model is valid when tire is in contact with road only. When one tire doesn't touch the ground, it will consider not valid. For the fourth scope, the simulation is only focused on suspension and linkage component. And for the last scope is only vehicle ride and handling performance would be considered. For literature review, the first article is an overview on vehicle dynamics. The finding on this article is the purpose of vehicle dynamics, which is to support the vehicle during driving, and force in vehicle dynamics, which is vertical force, lateral force, and longitudinal force. Vehicle dynamics, which plays a vital role in finding out the right balance between driver feel, comfort, and safety of passengers during driving. For the next article, the title is Suspension and Handling. The finding in this article is vehicle handling performance. Handling performance is where the condition of the vehicle in cornering. Handling performance can be measured by observing the roll angle of the vehicle. The factor that affecting handling performance is by force exerted by the ground, by the atmosphere, and by the gravity. Article. The title is Automobile Ride, Handling and Suspension Design. The finding in this article is vehicle ride performance. Vehicle ride performance is important to a vehicle to make the driver and passengers in comfort. Ride performance is when the vehicle can absorb the uneven road profile. The factor that affecting ride performance is high frequency vibration, body roll and pitch, and the action of spring that is usually related to the smooth ride. The last article, the title is 14 Degree of Freedom Vehicle Model. The finding in this article shows the degree of freedom for a vehicle. There are 14 degree of freedom. The sprung mass has 16 degree of freedom, include the longitudinal, lateral, vertical, roll, pitch, and yaw motion. Each of the wheel allowed to have 2 degree of freedom, which consists of the vertical motion of the wheel and the wheel spin. For methodology part, this is the methodology during FYP1 where the problem were defined. Then, understanding of vehicle dynamics were done by research, and understanding CarSim software were done by doing the tutorial in the software. Next, during FYP2, the simulation were held using CarSim software. When the results were obtained, the results were discussed and conclusion will be made to determine which vehicle or model is the best. Then the discussion will be in the thesis documentation. Next, there are 5 values of sprung mass. For non-armored vehicle, the sprung mass of the vehicle is 2,725 kg. So for each person, it is 65 kg for each person. So for non-armored vehicle, one passenger, it is 2,790 kg. For 7 person, 3,181 kg, and for 9 person, 3,312 kg. For armored vehicle, the sprung mass of the vehicle is 5,000 kg. So for armored one passenger, it is 5,065 kg, and for 9 passengers, 5,652 kg. Of my study, there are 2 types of tests, which is double lane change and bounce and sweep test. The picture shows the route for double lane change test. The data collected from this test is hand wheel steering angle, roll angle of sprung mass, and vertical force at each tire. Hand wheel angle. Steering play important role in a vehicle. The vehicle will follow the input from the steering. The steering will control the car to stay at the route and control the stability of the car. Steering can make sure the vehicle always in control to prevent crash. Based on the graph, armored vehicle 9 passenger produce the highest value of steering angle during the double lane change test, while non-armored one passenger vehicle produce the minimum value of steering hand wheel angle. Angle of sprung mass. Armored vehicle 9 passenger produce the highest value of roll angle during the double lane change test, while the minimum value produced by one passenger non-armored vehicle. Roll angle is produced from centrifugal force. which is the equation can be defined as F equal to mv squared over r. M is equal to the sprung mass. When the mass is increased, the force also increase. The force also can be defined in torque equation, which is torque is equal to Fd, where the d is the distance from the root to the sprung mass center. So when the sprung mass center is high, the torque of centrifugal force will be increased. So to reduce roll angle, the distance from root to sprung mass center need to be reduced. Force at each tire, based on all the graph, armored 9 passenger produce the highest value of vertical force at each tire, while 1 passenger non-armored vehicle produce the lowest value of vertical force at each tire. Vertical force can be referred to normal force, which the force act to support the weight of the vehicle. Normal force is defined as F equal to mu n. When the mass increase, the force of the vertical force or normal force also increase. For the result of the next test, which is bounce and sweep, pitch angle of sprung mass, vertical acceleration of sprung mass, and spring compression will be collected. Bounce and sweep test is the test where the vehicle will pass through sine wave road profile of sprung mass. From this data, vibration that passenger and driver feels can be observed. Pitch angle is where the vehicle experience dive and squat. From the graph, armored 9 passenger produce the highest value of pitch angle, while non-armored vehicle 1 passenger, 7 passengers and 9 passengers produce the significant value of pitch angle. For vertical acceleration of sprung mass, from the data, we also can measure the vibration that passenger and driver feels in the cabin. Armored 9 passenger produce the maximum value of vertical acceleration, while non-armored vehicle 1 passenger, 7 passengers and 9 passengers produce the significant value of vertical sprung mass acceleration. For armored vehicle, there are a pattern for the graph where at 2.5 seconds, the value of vertical acceleration is the highest from 0 second to 5 second, and then it decreasing until 10 second, then the value of vertical acceleration of sprung mass become the highest value. Collected from bounce and sweep test is spring compression. The purpose of spring compression is to absorb the vibration from the road profile. It will absorb the uneven road profile to make the passenger feel comfort. spring can be defined as F equal to Kx, where K is the spring coefficient and X is where the displacement from original to the last state. When the displacement is high, the spring force also high. The higher the mass makes the displacement also get higher. So from the graph, armored vehicle 9 passengers which have the highest mass produce the highest value of spring compression for the front tire and rear tire, while the least value of sprung mass, which is non-armored vehicle 1 passenger, produce the least value of spring compression. To summarize the data collected from two types of tests, the data were summarized using RMS value. From the RMS table, 1 passenger vehicle non-armored is the best vehicle because it have the least value of RMS for all of the data, while armored vehicle 1 passenger is the best vehicle for armored vehicle because it has the lowest RMS value of the data. Conclusion of this study: the first objective is achieved by doing research to study the suspension system behavior of armored personnel carrier. For the next objective, the simulation were success by using CarSim software to make a model from parameter of Toyota Land Cruiser J200. And last, the APC cannot use the standard suspension due to the data increasing above 50% from the standard vehicle. Usually, manufacturer will produce the optimum suspension system to the specification of their vehicle. There are some recommendations to the future. First, researchers need to understand how to use CarSim software well, so that it's easier to run simulation using the software. Next, researcher need to validate the vehicle modeling using simulation and experiment method so that the comparison of result can be carried out and the best result will be obtained. And the last recommendation, next researcher need to make longer bump to prevent shock at rear tire and irregular graph pattern when doing the right test. All from me. Thank you.